Friends, let's talk about turning effect of force. Turning effect of force can be called as torque or moment of force. So let us try to understand by these three examples here. An object can be turned or can be rotated about a fixed point or an axis of rotation or a supported point. Take the case 1. This is the hands applied by a water tap is here. Two fingers act on a two hinge of this. This is the point of axis of rotations and this is the fixed point pivot. Now this is due to the application of this force by these fingers, and these fingers this produce a clockwise directions. This is moving in anti-clockwise direction with a fixed point about an axis of rotations. So it is producing anti-clockwise moment. In this case of the seesaw, this is the point of supported or the pivot or fulcrum. Two persons are sitting to each other. This is the force given by this person is acting in the clockwise directions, and similarly it's acting to the clockwise direction. This red color indicate this is the producing the force, moment of force about a turning effect of force about a particular point. This is the about a fixed or turning point. Now if we take an example of the spanner, so this is the longer handle, this is the load, and this is the fulcrum point of, okay. Now when force is applied, basically here arrow indicates the downward direction of the force effort. So what happens, it will in this case it produce a clockwise moment. Let more understands, if the person holds this spanner at the point A. Now student, this is the point of application of force applied, this is the point, and this is the load, the nut and fulcrum is there. So distance of the perpendicular distance from the pivot point to the application of force is longer. So in this case easy to turn the spanner very easily. But if you look the case 2, this force acting upward and the person holding the spanner very close to it, and the distance up from that effort force of application to this particular is a reduce. So it's very difficulty to turn the objects, to turn the spanner very easily. So here you can understand this, for this example force and D must be perpendicular to each other. Turning, D means perpendicular distance. Distance means point of application of the force to the pivoted point. For here the force is applied. This indicate the pivot of fulcrum. Okay, so distance from this acting downward, this force to this is a must be the perpendicular distance, line of action of the force. What is the line of action of the force? This is the point, and force is applied and from the fulcrum, and this load is acting to upward. So downward is effort is applied and here upward force is applied. So this is the line of action of force. Line of the action of the force from pivot point to the application of force must be a perpendicular distance. So force and D must be a perpendicular to each other, each other. So take an example of a door. This is the opening door. Three cases given A, B, C. These are hinge. These are three hinge given there, or fixed or supported ends. So here when we are pushing this one, pulling this one, we are use this particular portion, we are applying, this is the application of the force. So it's very easy to turn the object. It is very easy to turn the object in this particular point. So what happens, this object is opening to this side, so this is the axis of the turning, axis of the turning. So in this case the distance from the application of the force to the point of application of the hinge or supported point, it is a perpendicular to this one. So here is a perpendicular distance to this particular point. So perpendicular distance to the line of action of the force, hinge supported points. So for more understanding from this example, so this is the rough sketch of the diagram of the door. This is the pivot point, okay, and force is applied by this person at this point. So now distance from pivot point to the force is acting towards here. So this is the line of action of the force from the pivot point to the application of the force, or the application of the force to the pivot point. This distance is called perpendicular distance. So force and the perpendicular distance F and D must be perpendicular to each other. So this more precisely we can call the turning effect of force. Mathematically we can call moment, sorry, it also can be called moment or torque. That is, mathematically it is a force into moment arm. You should put in mind that moment arm actually a perpendicular distance. What is called force into perpendicular distance. There will be a lot of distances, but students, we are only considering the perpendicular distance with respect to the line of action of the force. So hope this video will be helpful to you. Thank you for watching my video.